Get started. Are there any questions of the homework? And so far, we've had two assignments, 661 and 662.
Wait, do we have, oh yeah, never mind. You posted it. I didn't know. I like your shirt.
Thank you. All right. What we're doing today is very similar to what we did Thursday with solving, except we're starting out with two logarithms on one side. Now, whenever we're solving these logarithmic equations, we need a single log on one side and all of our numbers on the other. Now, if we're ever given a starting point where we have more than one log, we need to get them on the same side. And for most of all we're going to do, they're already going to be there. If they're not, we've got to add or subtract them to both sides to get them on the same side. Questions on this so far? Now, the next thing we're going to do is use one of our properties of logarithms. And it's our product property, which states that log base b of m plus log base b of n is equal to log base b of m times n. If we have two logs with the same base being added together, we can rewrite them as a single log with what's inside being multiplied. Because this is also going along with our quotient property. Except instead of multiplying, we divide. Because if we have two logs of the same base being subtracted, we can rewrite them as a single log with what's inside being divided. Now, the reason this is helpful is because with our equation here, log of 2x plus a log of x minus 5 can be rewritten as a single log with what's inside being multiplied. So our 2x times x minus 5. Questions on this here? Questions on how we got to log of 2x times x minus 5 is equal to 2. Now we need to put both sides to our base to get the log to simplify out. Now what would our base be? It's not 2. What's the base inside the log? It's understood to be 10. So we're going to put both sides to the base of 10, because when we have log and the base is not written, it's understood to be 10. Our natural log's base is understood to be e. And this is helpful for us because 10 to the log base 10 is going to cancel out, leaving us with 2x times x minus 5 is equal to 10 to the second power, because we put both sides to the base of 10, but on the left-hand side are 10 and log base 10 cancel, leaving us with 2x times x minus 5, and the other side is 10 to the second power. Now 10 squared, 10 to the second power is a nice number. 10 squared is what? 100. Now the left-hand side, we can simplify this sum. 2x times x is 2x squared. 2x times negative 5 is negative 10x. Questions on how we got to this point here? Questions on anything we've done so far? Since we do have a quadratic, we have an x squared term, we need to get this equation equal to 0. So the next thing we can do is minus 100 from both sides. Minus 2x squared minus 10x minus 100 is equal to 0. Questions on how we got to this point here? What can we do next? Well, to solve this, we're either going to factor it, use the quadratic formula, or graph it. Which way do we want to use? Graphing. So if we want to graph it, we would take the graphing calculator. First thing we do is hit y equals. We can clear that out and say 2x squared minus 10x minus 100. And once we get that, we can hit graph. And again, when we graph it, we're looking for where it crosses the x-axis. Or in a table, we're looking for what values of x will make the y value be 0. And one of those is -5. And if we scroll down, the other one is 10. So here x is equal to -5 and x is equal to 10. We could have also factored or used the quadratic formula. Either way would have worked. Questions on this here? Now I'm going to check these here, because what we started out with, log of 2x plus log of x minus 5 is equal to 2. The first value of x I'm going to check is 10. So we're going to plug 10 in for x and check to see if this does give us a true statement. I'm ahead of myself. Because if we do this with 10, so 2 times 10 would be log of 20, plus log of 10 minus 5 is 5. So we're trying to see if log of 20 plus log of 5 is 2. Well, at this point, we'll need the calculator if we want to find out what log of 10 plus log of 5's value is. We're not finding log of 10. What are we finding? Log of 20. Log of 20 plus log of 5 is indeed 2. That's what we wanted. And that means it is indeed true. Questions on this here? Let's look at the next one. Because it'd be log of 2 times -5 plus log of -5 minus 5. Well, the first one, log of 2 times -5, would be log of -10 plus log of -5 minus 5 would be -10. And again, we can check this here. We say log of -10 plus log of -10 is domain error. And the reason we get a domain error, it doesn't work, is because the number inside these logarithms cannot be 0 or negative. Once we plug value of x in and simplify down, we cannot have 0 or a negative. So since there's a negative in both of these logs, it tells us that the only value of x that actually works for this here is 10. The x equals -5 is an extraneous solution. It's a solution that shows up in the process of solving, but does not work in the original problem. Questions on this here? Be ready for the next one. So as we see here, for the most part, this isn't a big change from what we did Thursday. It's just adding one step. Because if we look at the next one, log base 6 of 6x plus log base 6 of x minus 1 equals 2, well, we need to take these two logs and rewrite them as a single log, which would give us log base 6 of what? Be 6x times x minus 1 is equal to 2. We take what's inside both these logs and multiply them together. Questions on this here? What would we do next? Put both sides to the base of what? 6. Because our 6, log base 6 would cancel, leaving us with 6x times x minus 1 is equal to 6 squared. Now our 6 squared is 36. Our other side, we can distribute the 6x. Our 6x times x is 6x squared. 6x times negative 1 would be negative 6x. Questions on this here before we do our next step? Are you ready for the next step? So since we do have a quadratic and x squared term, we need to get this equal to 0. So we can subtract 36 from both sides. Telling us that 6x squared minus 6x minus 36 is equal to 0. Now again, at this point, we could graph it. We could factor it either way. 6x squared minus 6x minus 36. Graph. Well, we'll see, we do see the two spots where it crosses the x-axis. And we go second table. These two spots are at negative 2 and 3. So here we're saying x is equal to negative 2, and x is equal to 3. Which one of these two values do we think will probably not work? So our two solutions were negative 2 and 3, yes? So which one of those two is probably not going to work? Negative 2 is probably going to be the one that doesn't work. Now when we check it, we could do exactly what we did on the last one and write the whole thing out. But really, what are we trying to see and make sure that 6x and x minus 1 are not negative or 0? Because if either one, doesn't have to be both, if either one of those is negative, it doesn't work. So if I look at 3, well, 6 times 3 is 18. That's fine because it is not 0 and it is not negative, so we're good. The other one, our x minus 1, would be 3 minus 1, which is 2. Both of those are not 0 or negative, and they actually do work. Because here we did our steps correctly, so those should be our two solutions. Or this here is just verifying that 3, x equals 3, is a solution, that it will not give us a 0 or negative inside the log. Because if the number inside the log is 0 or negative, it doesn't work at all. Because our other solution that we had was negative 2. Well, 6 times negative 2 is negative 12. We can't have that here. And even if we check the other one, it would give us negative 3. So that tells us that negative 2 is not a solution. 3 is the only solution that works with this here. And it's really coming back to our properties of our product properties. Because when we multiply -3 and -12 together, we get positive 36. So log base 6 of positive 36 is indeed 2. But with it split apart, we can't have it being -3 and -12. Questions on this here? I feel pretty comfortable with this here. Yes? All right. We're going to do one more of these here, but I'm going to change it a little bit. So instead of log, we're going to use ln. Instead of log, we're going to use ln. Now, even though it is the natural log instead of log, our first property still holds true. Since we have two logs, two of the same logs being added together, I can rewrite it as a single log with what's inside being multiplied together. What can we do next? We would put both sides to the base of e. Because our e, the ln's base is indeed e. So e to the ln would simplify out, leaving us with 5x times x minus 1. On the other side, we have e squared. So what is e squared? Is it a nice number? No. E's irrational, so squaring it is not going to make it rational. So we're going to leave it as e squared. Now at this point here, on the other side, we can still distribute the 5x like we did on the last one, which gives us 5x squared minus 5x is equal to e squared. Questions on this here? Now, since we do have an x squared term, we need to get this equation equal to 0. So for this one here, we're going to subtract e squared from both sides. And when we subtract e squared from both sides, we get 5x squared minus 5x minus e squared is equal to 0. Now we could try graphing this. It will cross the x-axis in two places, but they're not going to be nice numbers. Incidentally, we're not going to be able to factor it either. So the only other method that we have for solving these, besides completing the square, is the quadratic formula. Because we could complete the square with this. It's not going to be nice. It would not be pretty. It's going to be a little bit easier to use the quadratic formula. And again, we're getting our a, b, and c from our ax squared plus bx plus c. A in our case would be 5. B would be -5, and C is actually negative e squared. E squared is still a number. E is a number. So we can still plug it in. We can still do this. Questions on this here before we move on to our next step? Now at this point here, we're going to plug in our value. So our next first thing is negative b. So it'd be -5 plus or minus the square root of b squared. So it'd be -5 in parentheses squared minus 4 times a. Well, a in our case is +5 times c, which is -e squared, all over 2 times a, so 2 times 5. Questions on this here? Questions on anything we've done so far? Now from here, normally we would type in what's inside the radical before we take the square root, but it's going to be an irrational number, so it's going to be a non-repeating, non-terminating decimal. So we might as well type the whole thing in all at once. So we can grab either calculators, have our fraction, negative, -5, plus second square root, -5 squared, minus 4 times 5 times negative e squared. To get our e, we do second ln. Second ln will get you e all over 2 times 5. Once we type the whole thing in, we just hit enter and let it do it for us. 1.814. So x is approximately 1.814. Now again, because it's a quadratic, we should have 2 solutions. Any questions on how we found 1.814 before we find the other? Well, there's 2 ways to find the other solution. Is we can type this whole thing again, but instead of having plus in front of the radical, we're going to have minus. The other way is I can come back up and highlight it and hit enter. And what I would do is go back over and put the cursor, the highlighter over the plus, and hit minus. It'll replace it. Enter. It'll give us the same thing, but instead of having the positive square root, we have the negative, and it gives us negative 0.814. So these here are our 2 solutions. Will both of them work? The negative one will not work because here we have ln of 5x plus ln of x minus 1. Well, 5 times negative 0.814, 0, 7, would be negative 4.07, negative number, so it is thrown out. So our only solution for this here is x is equal to 1.814. Questions on this here? Well, we're going to keep working it through, but the value of x for these here cannot be negative inside the log. Log of x. So if we look at the graph of just log of x, as we see here, it starts at the y-axis and moves to the right, which means any value that we plug in for this here doesn't work. So it's an error. And part of the reason for this is we'll just take here ln of 5x, this equation, yes? If I wrote it in exponential, where you do e and e, those would cancel. 5x is equal to e to the y, yes? Well, again, we said that this value here cannot be, let's just say 0. Because if it was, it's just saying that we have e to the y while the 5x is 0, yes? Well, as we've seen here, e to the first would just be e squared is not equal to 0. We keep going up, it's not going to get equal to 0, it's just getting farther away from it. So the other option is that, well, is that maybe y's value is negative. Well, if it's negative, that's just 1 over e to the second, yes? Well, that's not going to be 0, because the only way a fractional answer can be 0 is if the top is 0. Well, it's 1, so it's not going to be 0. Well, the only other option is if the exponent is indeed 0. But anything to the 0 power is, so there's no way to make this negative, or well, make it 0. But if you look at all these here, this is greater than 0, this ends up being greater than 0, well, that's 1. Well, none of them are negative either. So what's inside cannot be 0 or negative. Does that make sense? So it's kind of working a little bit backwards to get there, but not so much x value, because it can be negative. X can be negative, because I could say log of x minus 7. Well, hold on. Go in the other direction. Plus 7. Second graph. Negative 6. I do have a value of x that is negative. But if you notice, the other value started now 0. We just moved the function over to the left. Now it's just saying x cannot be less than 7. Because if it's 7, we get 0. Stops working. So it's not so much the value of x, it's that what's inside the logarithms cannot be 0. We plug the value of x back in and check it. Doesn't mean it's not always true. Because if it would just say ln of x squared, well, let's not use ln, let's say log of x squared is equal to 2. We go through and solve this here. It'd be x squared is equal to 100. X is equal to positive negative 10. I know I skipped a whole bunch of steps, but if we plug it back in, log of negative 10 squared, well, negative 10 squared is 100. That's true, and the same thing would be true for positive 10. So we plug it back in to make sure. So it's not always the case that negative won't work, but with ones like this here, we do have x by itself, nothing to fix or counteract that negative, we start throwing them out. Questions on this here? I think we should feel pretty good with plus, because it didn't add too much to it. Just the fact that we rewrite them as a product. Subtraction. Again, we would rewrite it as a single log with what's inside being divided. Because when we subtract two logs, we rewrite it as a single log with what's inside being divided. So if they're being added, we rewrite it as multiplication. Here we rewrite it as division. Now this only really adds a stipulation if we do have a variable in the bottom of a fraction, because we would have to eliminate those as possible choices, anything that would make the division be 0. But for the most part, it's not too much of an addition, because if the second log would have had a 0 in it, it would be thrown out anyways, because we can't have one of these logs be 0. Next step, we're going to put both sides to the base of what? What's our number? 10. Because if it's not written, the log's base is understood to be 10. Well, forgot to fix that. Just the color anyways. 3x minus 2 stays the same. 10 to the third. Is 10 to the third a nice number? What is it? No. 10 to the third is 1,000. So when I talk about us simplifying it down if possible, or leave them as log or exponential, if it's not a nice number, so our e, because if we have e to a number left over as part of our answer, leave e. If it's like this here, 10 to the third, 7 to the fourth, where we can rewrite the number nicely, rewrite it. Now at this point here, we need to find the value of x, yes? Does our x, our variable, have an exponent other than 1? Well, no, it's just x, right? Get it by itself. So what can we do first to get x by itself? Well, we could divide by 1/2 or multiply both sides by 2. Because our left-hand side, when we multiply by 2, will leave us with 3x minus 2 is equal to 2,000. Then what would we do next? We would add 2 to both sides, which will tell us that 3x is equal to 2002. Yeah. And lastly, we would divide by 3. Does 2002 or 2002 divide by 3 nicely? No. The easiest way to check to make sure that a number, or see if a number is divisible by 3, is add the digits together. So here we'd have 2 plus 0 plus 0 plus 2, which is 4. If that number is divisible by 3, then the original one is also. 4 is not divisible by 3, so 2002 is not divisible by 3. So that's our final answer.
Any numbers or no, just 3?
Huh?
Is that work for any numbers? Just 3?
3 and 9. Mm-hmm.
Not 6.
No, 6 is 2 and 3. If 2 and 3, if a number is divisible by both 2 and 3, then 6 is 2. Well, 2 times 3 is 6, so. And that's it. That's all we're doing with 6, 6, 3, 3.